So suppose these are the given vectors. We have 8 Newton and 3 Newton. Uh, Suppose these are the two given vectors. Vector A, whose magnitude is 8 Newton and it's 110 degrees from positive x-axis in counterclockwise direction. And then vector B has a magnitude of 3 Newton and 45 degrees from positive x-axis in counterclockwise direction. So we cannot draw a line of 8 Newton. Instead, we do scaling. So I will have a scale of 1 cm is equivalent to 1 Newton. So the first thing to do is to make a x and y axis. Okay, in graphical method of determining the sum of vectors, you must lay the vectors one after another by placing the head or the tail of the succeeding vector to the head of the preceding vector. So we're looking for vector A plus vector B. So we need to lay first vector A. So it's 8 Newton, 110 degrees from positive x-axis in counterclockwise direction. So we will have an angle of 110 degrees from positive x-axis. So you look for 110 from positive x-axis. So you start here. You start at 0 and then you look for 110. So this is 110. Make a dot. And then vector A has a magnitude of 8 Newton and I have a scale of 1 cm is equivalent to 1 Newton. Since the magnitude is 8 Newton, then I'll have a line from the origin passing through this point and has a length of 8 centimeter. Okay, so we have now vector A. This is vector A. 8 Newton, whose magnitude is 8 Newton, and the direction from positive x-axis is 110 degrees. Alright, so that is vector A. So next is vector B. Okay, vector B. The next thing to do is to make another Cartesian coordinate system whose origin found at the tip of vector A. So we will make another horizontal and vertical line. Make sure this line here is parallel to the x-axis. And this line here is the y-axis. So we have another Cartesian coordinate system whose origin found at the tip of the head of vector A. So we can now lay vector B. So next is to look for 45 degrees from positive x-axis. 45 degrees. So we start at 0 to 45 degrees. And make a dot. And then again the scaling is 1 centimeter is to 1 Newton. So I'll have a line from the tip of the vector A passing through this point with length of 3 cm, since the magnitude of vector B is 3 Newton. So 3 cm. Alright, so we have vector B. Magnitude of vector B is 3 Newton, and then it has a direction of 45 degrees from positive x-axis in counterclockwise direction. The vector drawn from the tail of the first vector to the head of the last vector represents the vector sum. So next is to make a line from the tail of the first vector to the head of the last vector. So this line here represents vector A plus vector B. Alright, and then measure the line. So that's approximately 9.6 cm. Okay, approximately 9.6 cm. So vector A is 9.6 Newton, since we have the scale of we do scaling. 1 cm is equivalent to 1 Newton. So you have 9.6 Newton, comma, and the next is to measure the angle. Measure the angle from positive x-axis. So that's approximately 94 degrees. Oh, wait, 94 degrees. Right? So this is example number 1. So vector A plus vector B has a magnitude of 9.6 Newton, comma, and direction from positive x-axis of 94 degrees. Okay. So we have the second example, but the same given. We have vector A, which is equal to 8 Newton, 110 degrees from positive x-axis. And then vector B is 3 Newton, 45 degrees from positive x-axis. And again, we do scaling of 1 centimeter is to 1 Newton. And this time we look for vector A minus vector B. So, and the first thing to do is to make a Cartesian coordinate system, or x and y axis. So next, we need to lay vector A. Since the angle of vector A is 110 degrees from positive x-axis in counterclockwise direction, measure 110 degrees from positive x-axis. You look for 110, then make a point, and then draw a line from the origin that is 8 centimeter, and then should pass through this point. So we have vector A, whose direction is 110 degrees, and then whose magnitude is 8 Newton. Okay, next thing to do is to make another Cartesian coordinate system whose origin found at the tip of vector A. So make a horizontal and vertical line. And then we can now lay vector B. Now, look for 45 degrees. Since this is negative vector b, instead of going at that direction, instead of measuring the angle from positive x-axis counterclockwise direction, you measure the angle from negative x-axis in clockwise direction. So you start 0 here and you look for 45 degrees, since that is negative vector. So make a point, then make a point. The next is to make a line from the tip of vector A, and the length is 3 centimeters. Wait, we have negative vector B. Then this direction is 45 minus 45 degrees from negative x-axis, and then whose magnitude is 3 Newton. And then make a line from the tail of first vector to the head of last vector. So this line represents vector A minus vector B. Then measure the length of vector A minus vector B. That's approximately equal to 7.2. Okay. So vector A minus vector B is 7.2 Newton, comma, the direction from positive x-axis. Let us measure it. That's 131.9, or approximately 132. Yeah, that's 132 from positive x-axis. Right. So vector A minus vector B is 7.2 Newton and 132 degrees from positive x-axis. Vector A minus vector B is 7.2 Newton and 132 degrees from positive x-axis. Example number 3. Suppose the given vectors are vector A, which is 8 meters 120 degrees, vector B is 3 meters 45 degrees, vector C is 3 meters 110 degrees, and then of course we cannot make a line, 1 meter line or 8 meters line in this single graphing paper. It's too long, so we'll have a scale of 1 cm is to 1 meter. And then we will look for vector A plus vector B minus vector C. So first thing to do again is to make a Cartesian coordinate system, or x or y axis, since this is a two-dimensional vector. We have Cartesian x and y axis. This is y and this is x. So we need to lay first vector A, which is 8 meters 120 degrees from positive x-axis. So you look for 120 degrees from positive x-axis, the protractor, then make a dot. Alright, and then you lay vector A, whose magnitude is 8 meters, so we have 8 centimeter line from the origin. Okay, so we have vector A. 120 degrees from positive x-axis, and then whose magnitude equal to 8 Newton. Okay, the next is to make another Cartesian coordinate system whose origin found at the tip of vector A. Then you lay vector B. Vector B is positive, so you have 45 degrees from the x-axis. And you look for 45 degrees from positive x-axis. Okay, and then make a line. Its magnitude is 3 centimeter or 3 meters from the origin. So we have vector vector B that is 45 degrees from positive x-axis, and magnitude is 3 meters. Then, since you have the third vector, which is negative vector C, make another Cartesian coordinate system whose origin found at the tip of vector B. Next is, since this is negative vector vector C, okay, instead of measuring the angle from positive x-axis counterclockwise direction, measure the angle from negative x-axis in counterclockwise direction. So you start 0 here, and then you look for 110 degrees. This is 110 degrees. And then make a dot, have a line whose length is 3 meters or 3 centimeters from the tip of vector B. Right. So this is vector C. That is 110 degrees from negative x-axis, and that's a magnitude of 3 meters. And then draw a line from the tail of the first vector to the head of last vector. The tail of the first vector is vector A, and then the last vector is vector C. So we'll make a line from the tail of vector A to the head of vector C. This line represents vector A plus vector B minus vector C. Alright, and then measure the length. Measure the length from the tail of first vector to the head of the last vector, and that is approximately 6.3. Okay, so we have vector A plus vector B minus vector C equals 6.3 meters, comma, measure the angle from positive x-axis in counterclockwise direction, then that is approximately 98 degrees. So by graphical method, vector A plus vector B minus vector C equals 6.3 meters and 98 degrees from positive x-axis in counterclockwise direction.